We can do one last example from section 6.4. Number 16 is towards the end and pretty representative. And number 16, they're talking about cans of Coke and that they're filled with the volume that's normally distributed with a mean that is equal to um, 12 ounces, so 12.00 ounces, and a standard deviation that is 0.11 ounce, so 0.11 ounce, and this is ounces. So that's the mean and the standard deviation. So it's very much like the last one that we did. Find the probability that a single can of Coke, so for A, they want to find the probability that just one can of Coke has a volume that is at least 12.19. And so we go and we draw our normal distribution. So this really is a 6.2 problem, although it's found here in 6.4. The mean is 12, and I care about 12.19. So I have to go find the z-score of 12.19 by subtracting away the mean and dividing by the standard deviation. So if we take the 12.19 and subtract away the 12, and then divide by 0.11, we get the number 1.727, so 1.73. So 1.73 is the number of standard deviations 12.19 is away from 12 under this setting. Well, that's going to help me because now I need to look at 1.73, and we need to look that guy up. And as we do, and go to the 1.7 row and the 0.03 column, we have 0.9582 displaying. Now, what we wanted was the area above 12.19, and what we got, this is what we wanted, but what we got is 0.9582 over here. So the probability that a single can of Coke has a volume greater than 12.19 is going to be 1 minus 0.9582. And if we do that really quick, we come up with 0.0418. So that is part A, to come up with 0.0418 in number 16. Now, there's a B part of that. And as I do this one, I'll show you a little bit different way to calculate that z-score. In B, what they have is they have 36 cans of Coke. And the question is, find the probability that the average of volume in those 36 cans of Coke is at least 12.19. So very similar question, except we're now looking at the average of 36 Coke cans. So my picture will essentially look the same. The mean for the 36 cans would be the mean for the individual of 12.00. We still care about 12.19, and we still care about being above it, being at least 12.19. What we do know is that we have a new standard deviation, which is the old standard deviation of 0.11 divided by the square root of the group size, which is 36. So instead of calculating this out and writing some decimal approximation, the book would probably suggest that we find our z-score for 12.19, subtracting 12, and then put this 0.11 all over the square root of 36. This is how it's going to have to be entered in the future sections. And so we might as well get practice with that here. So the biggest thing to remember is this bottom piece needs to be in parentheses when you plug it into your calculator. So you'll have it do the top and hit equals, and then divide by that parenthesis. And when you do, if you take your 12.19, subtract away the 12 and hit equals, and then divide that by open parentheses 0.11 divided by the square root of 36, you're going to get the answer, and it's big, 10.363. Well, that thing is way above 3.5, so we know when we look it up we're going to get 0.9999. So the probability that this group of 36 cans have an average volume of 12.19 or greater is actually 1 minus 0.9999, which for us is 0.0001. We know there's a lot more zeros than that, but that's the best we can do with the A2 chart. In this, you can see that throughout the 6.4, we're pretty much doing the same thing, recognizing that we have a group, getting a new standard deviation right away, and then using that new standard deviation in the old 6.2 format.